we're going to be finding the Maclaurin series of y all the way up to the x square term, which means that we need an expression for d square y dx square. So far, what we have is an equation for dy dx. So what I'm going to do is I'm going to take this equation and I'm going to try to differentiate it one more time to get an equation for d square y dx square. But to prepare my equation before I do in differentiation, I'm going to cross multiply this 2y over to the other side. That will give me 2y. Then dy dx, this is equal to cosine x. And then differentiating this with respect to x, we will have a 2y. Differentiating this product rule, d square y dx square plus 2. Differentiating this, it is dy dx multiplied by product rule once again. So this is going to remain constant. This is going to be equal to differentiating this with respect to x. This is minus sine x. So we will have a 2y d square y dx square plus 2 times of this times this. This is dy dx multiplied by dy dx, which is dy dx square. So this is this minus sine x. So we are going to try to find the values for y, for dy dx, for d square y dx square when x is equal to 0. So when x is equal to 0, according to the question, y is equal to 2, because this point 0, 2 falls on the graph of y is equal to fx. So we know from here, when x is equal to 0, y is equal to 2, because f0 is equal to 2. As for dy dx, this is equal to cosine 0 divided by 2y. Y is 2. So dy dx is going to be equal to 1/4. And d square y dx square, d square y dx square will be minus sine x is equal to 0, so minus sine 0 minus 2 times of dy dx square, so 1/4 square, and this is going to be divided by 2y. Y is equal to 2. And for this, we will be getting a minus 1 over 32. So now we are ready to form the Maclaurin series all the way up to the x square term. That will give us y, which is equal to fx also. Y is going to be equal to f0, which is y when x is equal to 0. So this is equal to 2 plus, then we will have a 1/4 f prime 0, 1/4 x. Then f prime prime 0, which is going to be this. So it is going to be minus 1 over 32 divided by 2 factorial x square and so on. So simplifying this, we'll get our answer. This is equal to 2 plus 1/4 x, then minus 1 over 64 x squared. And after we have gotten this, we are supposed to write down the equation for the tangent to the curve when of y is equal to fx at x is equal to 0. So we know a few pieces of information about what happens when x is equal to 0. When x is equal to 0, I know y is equal to 2. And we do know also the gradient. The gradient is equal to 1/4. So we know dy dx is equal to 1/4 when x is equal to 2. So now we can simply just code the equation of the tangent. So let me write it down here. The equation of the tangent is y is equal to mx plus c. M is equal to 1/4. So 1/4 x plus c, the y-intercept. That means when x is equal to 0, y is equal to 2. Part 2 deviates from the norm because this is a Maclaurin-centered question. But for us to be able to do part 2, what we will need to do is to apply a bit of differential equation. Because this is the differential equation that was given to us by the question. So in order for us to find y in terms of x, we are supposed to integrate this as a differential equation. This is a variable separable kind of differential equation. So I'm going to bring the y over to the dy dx side, like the strategy that I have highlighted on the Achevas TV. So we will have a 2y and dy dx. This is equal to cosine x. And integrating both the left and right hand side with respect to x, we will have this on the left hand side, and on the right hand side it is going to be integrating cosine x. So it is going to be this. So we have a 2 integrating this is going to be y squared over 2. And this is equal to integrating cosine x gives us a sine x plus c. So what we have now is a y squared is equal to sine x plus c. We will be able to solve for c because we know that when x is equal to 0, y is equal to 2. So I'm going to substitute it into here at the point 0, 2. When x is equal to 0, y is equal to 2, we will have a 2 squared is equal to sine 0 plus c, and sine 0 is equal to 0. So this tells us that c is equal to 4. So we have a y squared is going to be equal to sine x plus c, which is sine x plus 4. But since what we are supposed to show is 4 plus sine x, I'm going to just write it as 4 plus sine x instead, which means that y is supposed to be plus or minus square root of 4 plus sine x. But we are going to be rejecting the negative because we know that when x is equal to 0, y is supposed to be equal to positive 2. So it cannot possibly be a negative here. So we will have a positive square root of 4 plus sine x. And let me write down the reason here. This is because when x is equal to 0, y is equal to 2, which is a positive number. So this is what we are supposed to be showing according to what the question says. So what we have done is to show it. Since x is sufficiently small such that anything that is x to the power of 3 and higher powers are going to be in naught. So if I were to refer back to my formula sheet, I know sine x is going to be approximately x. So this, I'm going to rewrite it as approximately 4 plus x, because x to the power of 3 is going to be neglected. And this, I'm going to write it as this to the power of half. So we're going to be doing a binomial expansion. So from here, I'm going to factorize out 4. So 4 to the power of half, which will leave me with a 1 plus x over 4. Then to the power of half. 4 to the power of half, this is equal to 2. So this is going to be 1 plus half, then x over 4 plus half, then minus half divided by 2 factorial, then x over 4 squared, and all the way till infinity. And I'm going to approximate this as 2 times of, if I were to evaluate this, it is going to be 2 times of 1 plus x over 8, then minus x squared over 1 to 8. So multiplying 2 in, this will give me a 2 plus x over 4 minus x squared over 64.